Hi, everyone. It's my pleasure to be here today. Today, I'm going to tell you about summarizing narratives with GPT-3 and what I think we need to measure the next 5 years of progress in this area. In order to think about the next 5 years, I want to start by thinking about the previous 5 years. So if we look back at 2017, one of the state-of-the-art models for abstractive summarization was the pointer generator network by ABC et al. And this built on sequence-to-sequence models with attention, which you can see here at the top, and kind of integrated additional mechanisms on top of this. And we could see that looking at the baselines, these systems were not really working that well. They were generating unknown word tokens, and they were making kind of blatant factual errors and kind of disintegrating as you tried to generate a long summary. And the pointer mechanisms helped, but it also ended up making these systems very extractive. So we still didn't really have great abstractive summarization systems. All right, well, let's fast forward to today. What do we have? So this is work by Jeff Wu et al. From OpenAI on recursively summarizing books with human feedback. And I think this is one of the most impressive summarization systems I've ever seen. You can take an entire book like Tale of Two Cities, and I'm just showing a short snippet of it here, and put it through multiple layers of a reinforcement learned, kind of fine-tuned with human preference judgments version of GPT-3, and produce a summary of sort of a chunk of the book, and then feed those chunks into another layer, feed those chunks into another layer, and after 3 layers of this, here's what you get out. Miss Manette receives a letter from the bank informing her that information about her father's small property has been discovered. She wants to travel to France to identify him and restore him to life. Mr. Laurie explains that her father has been found under another name and is being held in a house in Paris. In court, Mr. Darnay is accused of treason, and so on and so forth. So this is clearly way ahead of the destabilized Nigeria's economy thing that we just saw. It's able to synthesize these details about the plot over a really long document context. These things unfold over the first few chapters of the book, and yet it's kind of being distilled down into just a few sentence summary here that's basically factual, understandable, and very abstractive. Let's take a little bit of a closer look at what actually happens in this summarization process. So this is the raw text of the book, which OpenAI calls depth 4. And then if we kind of put it through one layer of that summarization process, here's what we get at depth 3. So this blue sentence is a great example of the abstractive summarization capabilities of these narrative summarization models. On a Friday night in November, a man walks up the Dover Road next to the mail coach, and you can see all the kind of pieces in the source that this is pulling together. The horses are tired and the road is muddy, so the coach has stopped several times already. This is really impressive because the input does not actually explicitly say that the horses are tired. So maybe we're a little bit unsure about this. On the other hand, we know that the horses are stopping repeatedly, etc., so we can probably infer that they were tired. And then finally, there is a small error here where it talks about they were trying to get the horses to move and they refused. But in fact, if you look at the source, the team had capitulated and returned to their duty. So the horses actually did move. Now, fortunately, when we put this through another level of summarization, actually the error goes away. So we'll come back to that error in a little bit. But what I want to emphasize is that we have a few operations that are going on. First, we're going from this kind of Dickensian literary style to a sort of more terse, prosaic, like, here's how the events unfolded style at depth 3. And then we're also kind of prioritizing content, abstracting, fusing sentences together, combining stuff, all those kinds of operations we associate with these types of systems. So I think if you're excited about summarizing books, then these results should excite you a lot. And even if you're not, I think that this is a great test bed for thinking about long-form summarization. One reason is that it's naturally occurring. I think this is important for our tasks, and there are existing corpora of summaries that exist, and we know that people look at them. It's also a very abstractive problem, and it has to be abstractive. For a lot of other summarization systems, I think you can think about if you had an extractive system with the right tooling around it, you might be able to do pretty well. But you just fundamentally can't show me a few sentences from a chapter of a book and let me get the idea. So the question is, given how kind of impressive that one summary looked, how can we evaluate where we are and where we need to go? And that's going to be the main focus of this talk. So the challenges that we've historically associated with summarization systems are things like, how do we make sure that the generations are grammatical? Well, we're a little bit past that now. Most of the generations from these systems are very high quality. They don't make a lot of grammatical errors. Relevance is a really interesting point that we're not going to touch on too much today. It's a little bit subjective in these cases. I think when you look at a book, different people can kind of emphasize different aspects of it and kind of think that different characters' arcs are more or less important. But regardless, I think these systems at least pass some kind of minimal bar of relevance. And I think it would be great to see more work on how to evaluate this in a fine-grained way. All right, so coherence, however, is one of the big things that we're going to touch on. And the reason it's really important is because unlike a short news article where you can kind of get away with like dumping a bunch of facts and bullet points at people and they basically get the idea of what happened, that's not true here. We need to actually weave things together into a narrative that tells a story. And that's the only way that the reader is going to understand what's going on. And then, of course, something that's a big question in all kinds of summarization is factuality or faithfulness to the original source. And we already saw some problems here. For example, this thing about the horses refusing to move when they actually did move, but also the thing about the horses being tired. It's a little bit tricky to actually confirm that that's correct. That's the kind of thing that might be open to interpretation. So I think we're going to need advances on these last 2 points. And they're obviously areas that have seen a lot of work in the greater ACL community and computational linguistics and NLP in general. But when we think about evaluation, we have to keep in mind the types of systems that we're evaluating. Now, remember in 2017, our systems look like this. It's very easy to kind of critique this system and say, hey, this is less good than a human reference. This is the same news article summarized with GPT-3. So it's not the same system as the book summarization stuff, but still the same kind of underlying large language model. And you could see that the quality of this is really, really good. It sticks close to the facts from the article. It kind of weaves things together. It basically works fine as a summary. And our evaluation methods are going to need to focus on whether or not they can be effective for these state-of-the-art summaries. And so for this talk, that's going to start with at least BART or T5 size, several 100 million parameter models, which I think in the next year or two, we're probably going to view as obsolete as we continue to scale stuff. And we're also going to look at primarily GPT-3 narrative summarization and how we can critique that. So I'm going to touch on 2 threads today, primarily focusing on the first one, on evaluating coherence of these narrative summaries. That's going to turn out to be one of the first order things that we see when we look at them, and we need better ways to attack it. So this was work led by my student Tanya Goyal, which is going to be presented at EMNLP. So let's revisit that summary we had of Tale of Two Cities. So we start off talking about Miss Manette. And I think if you're willing to sort of accept that, okay, this is going to be a character in this story, I'm going to learn more about her as we go, that might be okay. On the other hand, when we typically introduce someone new to in a discourse and the reader or listener doesn't really know who they are, we're usually going to give a little bit more detail. And so we're kind of dropping this new character here without a lot of introduction. And without a lot of preamble. And that's something that makes this, I think, a little bit harder to understand than it otherwise could be. If we keep going, we also see that the system is kind of doing this nice job talking about Miss Manette, Mr. Laurie, and then suddenly it starts talking about in court, Mr. Darnay is accused of treason. This is a very abrupt transition, right? We just totally changed the setting, we changed the characters, and we're, at least I'm not really sure what's going on unless I go back and look at the original book. However, he is acquitted after his patriot friend Roger Clyde testifies against him. This is a little bit trickier. When you read this, I think it's a little bit confusing because we think that, okay, if the friend testified against him, actually he should be convicted, right? I would almost expect either the these two somehow don't match, and the discourse connectives in between them don't really line up. I would think that it should say, like, despite the fact that his patriot friend testifies against him. And then finally, a little bit later, Charles Darnay tells the Marquis that he renounces his French property as it is full of misery. This is also a kind of statement where I think we need some additional context. What property does he own? Why is it full of misery? What's going on here? It feels like either as a reader, you're probably going to have some understanding of this, or it's, maybe Dickens being intentionally omitting details, but then the reader of a summary might still want to know that, hey, we don't know anything about this property. This is the first we've heard of it. So I think even though, we're holding the system to a really high bar, right? Even though it's grammatical, a lot of it's correct, et cetera, I think that this could still be improved by having additional transitions or clarification. So for example, we could imagine adding in a positive here, Miss Manette, a French woman raised in England. Same thing for Mr. Laurie. We could add some information about the kind of setting of the Mr. Darnay court thing. So we'll come back to the idea of adding information there, but we'll just kind of think of these as some of the errors or mistakes that we've pointed out so far. We also looked at this in the context of movie script summaries. So this is from a data set from Papalampidi et al. And we can look at a summary of this movie script using this sum to the n model from Yusen Zhang et al. And here's what it produces. Jetson and Minkler find out that the gun used in the shooting of Tuggle was identical to the one used to kill Hubley. They decide to go to LA to find out what's going on. Alistair finds out that his son is in Los Angeles drinking and having a good time. So we see some of the same stuff, right? Actually, like, this is all fine, but we've got characters that are being dropped in with no preamble. We've got references to things like the shooting of Tuggle is referred to in this definite way that makes us think that, oh, okay, we should know what this is, but we don't. And then similarly, why someone's getting shot and then someone else is drinking and having a good time? Again, very abrupt. So in this work, we focused on 4 types of coherence errors that we saw be pretty prevalent in these types of summaries. We also looked at a few different language and fluency errors, things like repetition, ungrammatical or nonsense sentences, and cases where co-reference was unclear, which is also arguably a coherence error, but the kind of ways in which this manifested often looked more just like the language model screwed up and output some kind of garbage, as opposed to some sort of failure of higher level planning. And what we're going to do is we're going to annotate data. And the other benefit of having these kind of language and fluency errors is that annotators can attribute errors to these categories rather than trying to shoehorn them into these 4 types of coherence errors that we've got here. So what we did was we annotated around 10,000 spans in system-generated summaries with these types of errors. We looked at 2 data sets, both the books and also these movie scripts, and we looked at 3 models, 2 different models for books and 1 for movies. There was a small amount of annotation that we did, and then we had a larger scale Turk task that used vetted crowd workers who, we kind of made sure knew the definitions of these various error types, and we were kind of checking what they were doing for consistency and stuff like that. So what this gives us is it gives us a large collection, a large set of data that's annotated according to these errors that we can now look at and use and analyze, and we're going to see what we can do with it. Here's what this looks like. The thing I want to point out, I mean, this basically looks like what we had before, but is that we have multiple annotators do each passage. And it's a very tricky task. And it's something where people are pretty high precision. Usually when they identify an error, it's really an error, but their recall isn't always great. Some people are just kind of willing to accept, oh, okay, we'll find out more, about the acquittal or whatever's going on later. And in reality, we would kind of, we would still like to flag it as something that could be fixed, even though it doesn't necessarily bother every reader. So you can look at the paper for information about annotator agreement, which, like I said, is a little bit kind of tricky here. But let's look at the overall distribution of errors that are annotated here and get an idea of what's going on inside these systems. So this is on the full data set. And the first 4 lines in this graph are these 4 principal coherence error types. The fraction of errors here is just the number of spans that are labeled with some error. So it's not normalized by tokens or anything like that. But regardless, what we see is actually across these different types of errors, coherence really is the sort of biggest thing. There aren't really that many of these language errors, things like repetition or grammaticality that plagued earlier systems. Now it's really about these sort of higher level misunderstandings in text. So most of the errors we see are due to coherence problems, and this holds up even when we break down and look across these different kind of data sets and models that we had. And interestingly, you could see that the 6 billion book model and the movie BART model have higher fractions of co-ref and grammaticality errors, whereas the 175 billion model really has very little here. It's about 10 to 15% of the data, just a little over 10%, fall into any of these non-coherence error types. So I think this is evidence that as we scale more, we're going to kind of see, basically these become even more of what we want to focus on. So armed with this data, we looked at whether it's possible to automatically detect these errors so we can critique these models. We trained a T5-based error detector that would take in a sentence like this in context and then output a set of detected errors. So in this case, we say there is a new character error, and that's associated with Miss Manette, and then we output a separator token. So we can predict things both at a span level and also at a sentence level. So this is just critiquing this last sentence. In court, Mr. Darnay is accused of treason, but it looks at it with all the context. And it outputs both a character error and then also a scene error. So we're able to output multiple types of errors, either sentence level or span level. We're able to output multiple spans, etc. And this error detector does pretty well, which is encouraging to us. So we fix the precision to be 0.7. So we kind of set our thresholds for detection, such that the model is kind of predicting right errors around 70% of the time. And we look at recall across these different categories. Now, inconsistent is the hardest here, and it's also hard to spot which events are kind of missing, references or need more context. But we do a pretty good job of recognizing these kind of rough scene transitions or when we're just throwing in new characters. And it's nice because even using a small model like T5, we can still critique GPT-3, which is really important that we don't have to be able to fine tune a huge model in order to understand the shortcomings of that model. We also compared to some prior work on coherence, for example, unsupervised heuristics or ways of producing synthetic data like shuffling sentences, and whether these are able to detect errors as well. And the 2 lines here on the left are kind of 2 fine-tuned versions of our system, so you can see that they're doing significantly better than these baselines. Okay, so I'm going to wrap up this part and then kind of shift to factuality. But what we see here is that coherence is a first-order problem, even in these summaries output by large language models. And doing this kind of coherence annotation at a fine-grained level, at the span level with these particular categories was really important. You can look at the paper for more details, but we didn't find kind of overall Likert judgments to be reliable. And this is going to open the door for things like post-editing summaries or, tuning more with reinforcement learning to reduce these kinds of errors. And I think this kind of stuff should excite you if you either want better narrative summaries or you want a test bed for thinking about coherence models. It's a real world setting where you can kind of see some improvement from better modeling. All right, I'm just going to spend a few minutes now on another kind of thread on factuality errors. So this is work from Lian Tang, Rio Kamoy, and also Tanya. And it basically is kind of thinking about some of the challenges that we're going to see going forward. So let's return to that example we had before about the horses had, the cart was heavy and the horses had to come to a stop. And so therefore the horses were tired. So Entailment is one of the core ways that people make these kind of judgments, and Roberta MNLI will say that this summary is neutral with respect to the book, meaning it's not necessarily entailed. We see other kinds of factual errors as well. Here's another one, which is a little bit more of a classic hallucination, where in Pride and Prejudice, Darcy asks at one point for Elizabeth's hand for dancing, and she accepts him. And the summary says that he asks for her hand in marriage, which is not how and she accepts without thinking. That's not how the story goes. So how do these existing factuality models work, and will they work for this kind of narrative summarization? So there are a few different threads of this using off-the-shelf entailment models, using an approach based on generating questions and then answering those same questions from both the summary and the document and comparing the answers, and also an approach from our work, dependency arc entailment. And I'm just going to show an example of that to give you a flavor of the sort of thing that these models can identify. If you incorrectly summarize, visitors to the Isle of Lewis will be hoping the clouds stay away on Friday for the solar eclipse. If you say visitors to the Isle of Lewis will be hoping to stay away, we're pretty good at saying, okay, well, there's a problem that it's not the visitors hoping to stay away, it's the clouds should be staying away, and it's not the visitors staying, it's the clouds staying, right? So there's kind of particular sort of dependency arcs here that are wrong. So if we think about how past work has evaluated these sorts of systems, usually we generate some summaries, we label some errors with annotators, and then we use a factuality model, one of these approaches like DAE that I mentioned, to predict errors. The problem is a lot of this work has relied on kind of previous generation annotations on top of summaries, and then using strong models like BERT to detect those errors. If we look at what happens when we actually use summaries from state-of-the-art models, things look a lot less good. So this was work where we did a kind of meta evaluation across 12 existing data sets with annotated errors. And if we focus our efforts on state-of-the-art models for CNN and XSUM, we see that on this balanced accuracy metric, where basically there's a sort of we're treating the error and not error sort of symmetrically, there's no approach that really does all that convincingly well and doesn't really kind of uniformly dominate the others. And moreover, if we look at the result in the literature, which were often on models from older summarization systems, we had kind of much higher accuracy. So this is just a picture of what the results look like on CNN if we restrict ourselves to these older models, and we can see that the results kind of look a lot better. So a lot of the strong results in the literature here don't really hold up when we're looking at state-of-the-art systems. So what are we going to need in order to advance the frontiers of factuality? We're going to need stronger entailment models with better data. The kind of, does this book page entail this sentence task, is something that's just out of reach of a lot of our models right now. And a lot of the existing document level NLI approaches that have been brought to bear don't really handle this. There's going to be subjectivity. Did these two people discuss or did they argue? That's a tricky distinction to make. And we're also going to need to be able to localize this stuff like we can localize coherence. The problem is it's much trickier to spot these sorts of things, so it's a lot harder for us to apply our same annotation methodology, but it's also hard to do it with things like these QA-based frameworks. We have some recent work that kind of shows some problems there. So this is kind of raising challenges that I think are going to be kind of in need of more work. So let me just briefly wrap up now. I think beyond thinking about kind of coherence and factuality, which I hopefully have convinced you of are two important things that we're poised to make progress on, we should also be thinking about whether our model's outputs are useful. Karen Spark-Jones talks about the purpose factors behind summarization, which are things like the situation, where they're going to be used, the audience, are they targeted at domain experts or lay people, and what are they actually going to be used for? I think in 2017, if we looked back at those summaries, there was so much to fix that we didn't even need to think about the users. And now that these summaries are getting a lot better, we probably should be thinking about who's the audience? What are they actually going to do with it? What do they care about? And then that can help drive this kind of evaluation as well. So to answer the question here, or the topic of how do we kind of move the next 5 years of evaluation, we have much stronger systems. We're going to need better evaluation metrics. We're going to need to be thinking about coherence, factuality, and we need to think about what users need. But I think if we do that, we can see some really awesome developments over the next few years, and I'm really excited to see where this goes. Thank you for attention, and I want to thank all my co-authors and the funding agencies who made this work possible. Thank you.